Hi guys, Ian here from Hobby Zone, and here is my FPV iron packs that we do, FPV power packs, and they're all 4Ss, 4S 35,000 milliamp, 4S 10,500 milliamps, 4S 14,000 milliamps, 4S 17,000 milliamps, and they're all different sizes. I've got it connected in parallel here, as you can see, just to discharge the packs that I didn't use for flying for the day. So we keep them all in storage voltage to keep them lasting as long as they can. Anyway, moving on, the idea of my concept, the proof of concept idea, whatever, was on RC Group. It was discussed that sometimes we might come in for a landing and on approach, which needs to be aborted and to go around. And if you're at the end of the packs of the lithium ion, due to the voltage sag compared to lithium polymer, excuse me, you might not have the wattage to go around if you're at the end of your pack. Okay, so don't recommend you to fly towards the end of your pack, but if you do, you might not have enough wattage power to put full throttle and go around, because the voltage of the lithium ion is sagging too low. It doesn't have the amps. You can't get the amps out of it. So this is where my concept of having the option of running, let's say this is your lithium ion, it is a 4-cell, let's say for example it's a 4-cell lithium ion, and having the ability to have a relay to switch between this and adding an extra pack or so in series. So my idea was have it a 4S lithium ion and a 1S lithium polymer. Just a single cell lithium polymer. Okay, why a single cell? Because if you've got the ability to switch with a relay via your spare control, a switch on your radio, to be able to switch at will whenever you want to, you can actually add a full voltage of 4.2 volts to your overall power system that's going to your ESC and your motor. So at any given time you're flying, you can actually flick a switch and instantaneously, without a break, without an interruption on the ESC or the motor or the flight, you will get an extra fully charged lithium polymer, 1 cell at 4.2 volts. And that makes a big difference when you need to emergency go around or you need the extra power to take off if you've got a very heavy loaded plane with a lot of lithium ion batteries. And a 1 cell lithium polymer, it can even be a 1 cell 2200. I believe a 2200 would do the job nicely. Even a 1300 would do it. It just depends how much capacity you want to carry as a redundancy or a backup. Okay, so 2200, for example, this example I'm using now is a 2S hard case car battery. Okay, it's only a 2-cell, 7.4 volts, 7.4 volts. I've got 2 of them. So as a single pack, it's a 2S. In series, it's a 4S pack. Now, this is my spare switcher on your remote control. This is simulating a spare channel, a switch. Flick, 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 flick. You can actually hear the relay kicking over. There you go. The clicks was the relay clicking over. Now, this relay, it looks like an automotive relay, but it is not. I had it specially made for me from a relay factory in China. Automotive relays are a 12-volt system, where this relay here is a 5-volt system capable of, I believe, 60 amps constant. So for this application, it's a bit of an overkill because current in total divided, if you got them in series, is basically dividing through all the single cells. So if you're pulling, let's say I've got 4-cell here, if you're pulling 40 amps, if you're pulling constant 40 amps or 40 amps, each cell will see about 10 amps, okay? So this is a 60 amp ESC. So having that current dividing, since we're going in series now, you can actually get a smaller relay at 5 volt. I believe you can get 5 volt 30 amp relays, which are basically half the size of these anyway. So moving on, this is a spare channel, a switch to control the relay, all right? And over here, as you can see, it's a little PCB board of a dead servo, just a 9-gram servo, which acts as an on-off for the relay. That one, you can PM me. I can give you more information if you need it, or ask me. I can let you know how this actually works. But from there, I can control that little circuit board of a dead servo, and that basically turns on 5 volt voltage from your U-back on your aeroplane to the coil, which pulls the relay over one position or the other position. From here, you've got a motor to ESC. ESC then sees whatever power you're giving it to it. And here is my throttle response, channel 3. So this is all simulating a control system from an aircraft. Your spare channel, control the switch, control the relay to select your battery, and here's to control your motor. So without further ado, let's go with a test. That is just a LiPo battery with an ESC, just to supply 5 volts to my battery tester. Here we go. As you can see. Now, at the moment, I've got my switcher on a 4S system. I can hear the RPM. Let's change it over to a... Now I've got 2S system now. Now it's running on just this pack, all right? The battery, what the ESC is seeing is only one pack. This is isolated by my relay, which I've selected here. Now let's turn it up. As you can hear, the RPM is quite low. Full throttle, that is full throttle. Okay, you're flying, you can rev the engine, flying normally on a lithium ion pack. This represents lithium ion. You're flying. And let's say you're at full throttle and you want to land. And you find that, hey, I've got not enough juice. You flick a switch. Whoa, and there you go. It's saying 4-cell now. That is 4-cell going to your motor. Flick it back. Now it's back to 2-cell. Alright, I flicked it back. You can hear the RPM. Now, to 0. I'm on 4-cell. Whoa, crazy. Flick it over. I'm on 2-cell. Full throttle. You can hear it's very low RPM because it's only on a 2-cell. 4-cell, 2-cell, 4-cell lithium. You've got an extra 1-cell lithium polymer. Like I said, having a 4S lithium ion and a 1-cell lithium polymer. So that concludes my theory and proof of concept, I guess. And this can be all very much neatened up and make it a small of a footprint, and the wire gauge can be small according to your amp draws, and the relay, like I said, can be smaller. Since adding an extra cell in series, that means the whole amperage is divided on the number of cells, the number of series that you have. Now, having said that, redundancy. Now, as we know with relays, when the relay is not powered, that means the coil is not energized, you've got a default position of where the switch wants to be. Because what it is the coil energizes and it pulls it over. And without the coil being energized, it will spring back to default. It's a mechanical switch. And having said that, what you do is, on the default position, you have your lithium ion pack on your default. So for whatever reasons, if your U-back or whatever, well, I guess if your U-back fails, your plane is going to crash anyway. But let's say your relay fails, or your little servo PCB board, it fails. It stops supplying 5 volts to your relay. Guess what? Your relay is in default position. It's on a lithium ion pack, the big pack that you fly on, okay? And mind you, the relay is only powered when you turn it on. When it's actually pulling over to connect in series, that's when it's actually physically using energy. Beside that, it's not using an ounce of power. Your relay doesn't use power at all. Okay, it's cold, it's sitting there, does nothing until you. Now it's pulling 5 volts from a U-back or your 5-volt system, and it's pulling about 250 milliamps. That's how much I measured it. Okay, so that concludes my test.